So we're going to do a little more talking about stretching and flipping, and then completing the square again with a little twist to it now. I think most of you kind of getting the idea how to complete the square to get it in vertex form, right? Yeah. Okay. So it shouldn't be too hard then, this one little tweak we have here on the second page. So they're going to kind of review about what the A does in the AX squared, okay? So if you guys remember, if we have the graph of y equals x squared, all right, which is just the regular standard, the vertex is at the origin, right? So it might look like this, right? I don't think we really need our calculator to do this, do we? Okay. What would the graph of y equals 2x squared do to this graph? Nope. Nope.
Down.
Yeah, it would like stretch it, right? Make it narrower, because it's gonna climb faster on both sides, right? So this is y equals x squared, and then if it's 2x squared, right, it makes it climb faster, doesn't it? Y equals 2x squared. And what about 4x squared? What would that do? Make it even narrower, wouldn't it? Okay. So if you think of your table of values, instead of just squaring it, right, you're squaring it and then doubling it, or then multiplying by 4, so it's going to climb faster. So y equals 4x squared would be even narrower, right? Yeah, this is going to climb faster, right? If you're multiplying it, generally. There's the exception we'll get to in a second, right? So part B, explain what is it we just talked about. What's happening when we multiply x squared by a, some number in front of it. I'm going to put a caveat in here. If, and this should be here, a is greater than 1. What's happening? The graph gets what? It gets stretched taller or narrower, right? So it gets stretched taller and narrower. And if that's all we're doing to it, does the vertex location change? The vertex stays where? What?
At the origin.
0, 0, 0, right? At the origin. Okay. So unless we do other stuff to it, the vertex isn't going to move. It gets stretched, all right? Could it get compressed or made fatter?
Yeah.
By doing what? No. No. You remember the caveat I just put up here?
A is smaller.
Okay, you're close.
It's a negative.
Let's not get to negatives because we know what the negatives will do.
It's like a,
Talk about in between.
It's a fraction.
Talk about in between.
If it's in between 0 and 1.
If the A is in between 0 and 1, right? If it's between 0 and 1, like for example, what?
1/2.
1/2, 1/3, 0.7.
Like any fraction or
Well, like 5 halves would be bigger than 1, right? So be careful. Just say between 0 and 1. And if you multiply between 0 and 1, it's going to, if you think of your table of values, right? Instead of, putting in an x and then squaring it, you put in an x, square it, and then cut that in half, right? And so your y value is a little smaller than it would be, right? So it's going to climb more slowly. And so it means it's going to get wider. And we know what the negative does to it, right? What does the negative do to it when we multiply? It flips it, right? Makes it concave down. But in either case, does the vertex location change? Okay, so let's think about what we know about stretching and flipping and see if we can match these up with its graph over here, right?
Wait, so basically that makes sense because the wider you get, the more zeros there are. So then just like the uncountable infinity, you can make this line thing.
If that makes sense in your head, Roll with that. It's countably infinite, yes, very advanced parlance mathematically that you're using. Just say,
I just watch a lot of these songs.
if you're cutting your table of values in half, it's going to climb slower, which makes it fatter, right? Okay?
It's like exponential.
Just think like if you're slower,
like,
then you get fatter. Yes.
It's like exponential, like where you cut it in half and it gets like, it's like it getting wider.
Yep. Yep, exactly right.
Then it's just getting closer and closer to zero.
Yeah,
but
it's
it's
the more
not.
you're talking about how you understand that it's making me.
So let's match up these equations with the graph, and we'll just put number 1, 2, 3, 4, and 5 over here by the graph. Okay? So take a look at number 1. Y equals 3x squared.
I think that's gonna be the
Well-
middle.
Well, which one of these would be the narrowest? Of all 5 of these, which would be the narrowest one?
3x squared.
This one would, but right? It'd be the narrowest one. And it would be concave which way? Okay? So the narrowest one concave up over in the graph. See which one we're talking about?
Yeah.
So let's put a 1 above one of its little arrows there. Okay. You get the idea? Well, no, it's easier that way. Okay, so think about number 2 then. Y equals 1/2 x squared. Would that
I
be-
think that one's the biggest one.
Would this be the widest one?
Yeah.
So it'd be the widest.
Yeah. I thought x squared was the.
X squared is like the normal standard one, right? Like up here. This one was our x squared. It was the widest of these because none of these are fractions. These are all greater than 1. Is that right? Okay. So it's the widest in concave which way?
Up.
And up. So,
Oh, wait,
You see which one it'll be?
-2 is the thinnest one
well, hold on.
on the left.
This one, we're going to put a 2 where on the graph?
The left.
The outside one on top, right? So that's 2. All right, the -2. Is that going to be wide or narrow or what?
It's the narrowest concave down one.
Okay, so it's the narrowest down. Which would be this guy here, yeah? Okay. Y equals x squared.
That's the normal one.
That's the one.
Yeah.
That's the normal one.
There's only one left on top, right? So it's going to be concave up, right? And the only one left on top, so 4 right there. And then y equals -x squared. It's going to be concave down, right? So this will be our 5, all right? Yeah. But now they get a little better sense of what multiplying by 8 does, right? Of course, we did like adding something at the end, moves it up and down, or if it's in parentheses, it moves it left and right, but what's the trick?
You put two,
We
we
put
put
two,
2,
three
3.
What do they do?
The bottom.
Three,
We put
so-
2 and 3.
That's supposed to be a 3 there?
Yeah.
Well, let's make it a 3. Okay. So they didn't do it here, but remember, if we add or subtract to the end of the function, it moves it up and down, right? Greater than half less than. If it's greater than 1, it climbs fast and gets skinny. Going for what?
No, I think so.
I'm not sure where you're at.
Yeah, just keep.
Maybe it'll clear up as we move along. But adding and subtracting inside of parentheses, remember, moves it left and right, but what was the trick?
Swap the sign.
Right, but opposite of what you, like, if you're thinking shifting vertex, right? If you're thinking of shifting the graph, it's opposite of what you think, right? If it's in the parentheses, but anyway. Okay. So now we're going to get back into a little more completing the square here, right? Turning points, I prefer the word vertex or vertices. That's plural for vertex, vertices, okay?
Vertexes.
Now, if it looks just like this, it's going to have its vertex at the origin, right? But if it looks like what we have in this exercise, that's likely not going to be at the origin, right? It moves somewhere. But we can figure out where the vertex is, right, by doing what to that equation? Completing the square. Okay, so there's going to be one little twist in here, okay? Now, what do you notice that's a little different about this equation than the one that yeah, there's something other than a 1 in front of the x squared, right? So usually you want to look for a GCF first, right? Maybe that'll go away. Is there a GCF? All right, so there's no GCF here, right? So just make note of that. So that's going to change things just a little bit. All right, so we have to deal with that too. Right? So they want us to put it in vertex form by completing the square, right?
Yeah.
Okay. Is there a GCF in these first two terms?
Yeah.
What would it be?
Yeah.
Well, 2x, but I want to leave the x in there. I just want to, all I want to do, I want to factor something out of these first two terms that leaves me a 1 in front of the x squared, right? Just the 2. Normally, if I tell you to factor, yeah, factor out the 2x. But, so let's factor out that 2. So we'd have y equals 2 times x squared minus 6x, right? Okay. And then I'm going to leave plus 11 on the outside. All right. Now, the thing in the parentheses I can complete the square on, right? Because what's in front of the x squared now? No, not yet. Do you see an x with that h up there? It looks a little like it, but it's not, right? Now, yeah, now there's a 1 in front of the x squared, right? Another question is, how many of these things do I have here in the parentheses? I have 2 of anything that's in the parentheses, don't I? All right, keep that in mind. I have there anything that goes in the parentheses. I have how many of them in this case? 2 of them. Okay, keep that in mind. This is where the little twist will come in. So 2 times, all right, x squared minus 6x plus what?
11.
No, I want to complete the square inside here. What's half of 6?
3.
Okay, so 3 squared in there, right? Okay. What did I just add to the equation as a whole? 3 squared? Squared. Yeah, that's a 3 squared. But what did I really add to the equation altogether? Just 3 squared? Just did I just add 3 squared?
Oh, no, you took 11 out and then added 3 squared.
Okay, big picture. For the whole equation, did I add 3 squared to this whole thing just now?
Yeah.
Oh.
No, you added just to the,
Okay, again,
no.
anything that's in the parentheses, how many of them do I have? Oh, 2 of them. So what did I really add to the equation? How many of these 3 squared did I actually add? 2 of them, didn't I? Right? So now to keep it even, I have to go out here. If I'm going outside the parentheses, I have to subtract more than just 3 squared. What do I have to actually subtract?
6 squared.
2 of them. I have to subtract 2. You see? You get it where I'm at now?
No.
Plus 11. Well, you guys just got done telling me that whatever's in the parentheses, there's 2 of them.
Yeah.
So to zero this thing out, right, normally we just would subtract 3 squared again immediately, right? But now there's 2 of everything, including these 3 squareds that got added. So I've got to subtract 2 of them if I'm going out here. You get me? Whatever's in here is double what you do, because there's a 2 in front of it. Yeah? Okay. So do you get now why just instead of subtracting 3 squared or 9, I have to subtract 2 of them? Because I actually have 2 of them here. Like if I distributed this 2, wouldn't it be the parentheses go away and it'd have 2 times 3 squared that I added? That's what I'm getting. You gonna get it now? That's the only little twist, right? So let's take this in. Y equals 2. What does this become in here? This we know. X. We just completed the square. Minus 3 squared. We just reviewed that yesterday, didn't we? Okay. All right. This is 2 times what? Which is 9, which is 2 times 9. Minus 18 plus 11. Now let's just clean that up. What's negative 18 plus 11? Which one is it? I'm going to let you, you need a minute to decide. Okay. All right, so the only difference is we completed the square, right? We added b over 2 squared. But we didn't just add one of them. How many of them did we actually add if we put it in the parentheses? 2 of them, right? What if there was a 3 out here? Then we'd have to go out here and subtract 3 of them, right? Because this doubles whatever we put in here.
So that's a negative 2 on like the first one, other one. That one's negative 2.
Why would that be negative?
No, I'm just saying, like if it was a different.
Oh, if that was a net, oh yeah, if it was negative out here, then we'd have to,
A positive there.
yeah. Right, exactly. Basically, you have to cancel this out. Whatever it is, you got to cancel it out. Otherwise, you don't have an equivalent. So, like, if we hadn't done this, this and this wouldn't be equivalent, right? These are equivalent equations. They'll make the same graph. If we don't undo what we added in there to like change the form, then they're not equivalent. All right, so part B. What are the coordinates of the turning point? Vertex. What is it now? 3, negative 7. So if you put this in your calculator,
Yeah, but it's a negative in the parentheses. And we can see.
it comes out, remember, flip the sign, right? You got to remember these things. When it's in the parentheses, sign flip. That's why, like, when it shifts it, it doesn't move it 3 to the left, it moves it 3 which way? To the right, okay? Now, if we were to make a table of values, remember I told you when you want to graph these, what do you calculate? Make a table and you look for the vertex, right? How do you find the vertex? From your table. Somewhere in your table, there'll be the 3, negative 7, and how are you going to know that's the vertex? Right? So, like on this side, if you put it, it'd be negative 5 and 1, and on this side, it'll be negative 5 and 1, right? Same on both sides of it. Okay? Everybody got that? When you're scrolling through your table, that's how you can find the vertex. But we just found it by putting it in vertex form. Right? So I think almost everyone knows how to complete the square. Do you get this only small little difference we threw in here today? If we have some number outside here, right, that's how many of them we have in there, and we have to cancel it out, right, correctly. So let's try one of these down here. So let's look at this one here. Now look what's in front of the x squared. Okay? So we want a 1 in front of it, right? Can we factor a 5 out of the first 2 terms? Yeah. So it'd be 5 times what? Plus 4x. Let's leave a little gap here, right? Because we know what we're going to do. Right? We're going to add b over 2. What are we going to add? Oh, you give me, I know, don't say b. Say the actual number. 4 over 2 squared. What's 4 over 2? So plus 2 squared, right? Now out here, am I just going to subtract? 2 squared is 4. Am I just going to subtract 4? What am I going to actually subtract? How many are in here? 5 of them. So minus 5 times 4, right? Plus 23. right? Because normally, we would have just subtracted 4 to undo adding this 4. But again, how many of those 4s did I actually put in the equation? 5 of them. So I have to subtract 5 of them again to make it the same as the original. Okay, so 5 times what? X plus 2 squared minus 20 plus 23. So y equals 5 times x plus 2 squared, what? Plus 3. Okay. Now, what are the coordinates of the vertex of this? -2, comma 3. Is it concave up or concave down? Up, because it's a +5, right? And is it getting wider or narrower because of this? Narrower. It's going to climb a lot faster, right? Okay.
This isn't the hardest thing I've ever done.
No, sure it's not.
Not the easy, but I don't like to think down that way.
Yeah, I know.
Just one thing.
I want to do,
Let's try it B.
I think we should do D. B-
Let's go to B. Just you let me think about which one we should do, because I've been doing this for a little while. Since before you were even a zygote, I've been doing this.
I know.
You know, a zygote, you can look it up later.
You know who's-
What should I factor out of here so that I have a 1 in front of my x squared? So you asked about that, I think, right?
No, I get it.
Somebody did, right? What if it was a negative?
Yeah.
Okay, so let's factor out a -2. What's that leave us with? X squared, what? Minus 2x. Let's leave a little space, right? What are we going to add inside there? Lord God. What's the B?
-2 squared. 4. It's 4.
Why not B over 2 squared like we've always done?
4 over 2 squared.
Where are you getting the 4 from?
It's 4.
It's 4, that's what it is.
What's the B?
4. And then 4 over 2.
The B is -2.
So that, I thought it was
So,
going to be.
so -1 squared, which is just 1.
So plus 1 squared. Right?
I started talking about the B in the equation. And then you're adding.
No, we factored out the -2. We got a new B.
And then you're adding 2 plus 1. I know.
Okay, so how many of these ones do we have in here?
Negative
-2 of them. So how do we cancel that out?
plus 2.
By adding 2 of them, right? So, or I could say subtracting -2 of them, right? I don't know. So let's add 2 of our ones, right? Plus 7. Okay? All right, what's this give us here? 2 times x minus what?
Minus 1.
That's, yeah, thank you.
Squared.
Squared
What was it? Plus 2 plus 7. Plus 9.
Plus 3.
plus 9. 3.
I don't understand.
That's like 3 plus 7.
Yeah, but 3 plus.
2 times 1 is 2. What are the coordinates of the vertex?
1, 9.
1, 9. Is this concave up or concave down?
Down.
Down,
Negative.
because the -a. All right, why don't you guys try part C on your own? Look back, it's this. The only thing different now is you gotta undo what you did by, well, in this case, it'll be 6 of the things you put in there. Okay, and we'll take a minute and do C. Let's do it, shall we?
Actually, I got 10, but then I heard something come out.
What are we going to factor out of these first 2 terms to get a 1x squared? 6. What's that leave us?
X squared.
Minus 4x. What are we going to add?
2.
2 squared. Now what are we going to subtract? 6 of the, that's 4, right? This is 4. So subtract 6 of those 4s. Plus 14. Right? Oh, here? Like, well, here? Oh, why would that be negative? We are already subtracting it here. So that's where you're negative on this, right? All right, you guys get that? Like, you got it when we just like, okay, added 4 and then subtracted 4. The only difference is now we've got 6 of them that we actually have. We've got to subtract 6 of them. That's all. That's the only difference. So what's this become here? X minus 2 squared. So that's negative 24 plus 14 is, what are the coordinates of the vertex? 2, negative 10, and it opens up. Okay, try the last one now. What are you going to factor out of the first 2 terms so that you have a 1 in front of the x squared? A negative 1. Okay, go ahead. Look at it then. So we're going to factor out, I think we all agree, a what? Negative 1. What does that leave us then? X squared plus 12x. Let's complete the square now. So plus what? 6 squared. Okay. But how many of these 6 squareds do we have? Negative 1 of them. How do we fix that? So plus 1 of our 6 squareds. Minus 33. Right? Right? Now, does anybody, did I lose anybody here? If I did, let me know. All right. All right, so let's clean up inside here. Y equals, I don't need to make it a y, just do negative, right? What? X plus 6 squared. This is 36 minus 33, which is plus 3. Yeah? Vertex is up or down? Because of the negative a in front of there. Okay? There's only one thing different when we complete the square with these, and that's that we have to undo what we added by subtracting, 6 of them or 2 of them or whatever it is. Okay? You do what? That's called homework. All right, let's look at the readings questions. Let's read over the first one there. Everybody read it on their own. What kind of functions are they? How did you know that? Holy cow. Kid finally read something. Quadratic, which means they make parabolas. You're asking about the minimum value. Where do you find the minimum or maximum value of any parabola? And it's what? Think of the graph. No.
The turning point.
What do we call that?
Vertex.
The vertex is either going to be a min or max value, right? Depending on if the parabola is what or what. Concave up or down. Okay. Hey, what's the vertex of the quadratic they gave us in the table? How do you know it's -2, -16? You just randomly pick those? Look on both sides of the 16, right? And then -12, right? I bet the 7 would be up there, right? So here, so what's the minimum of this one? What's the minimum value? That's not the value, that's the input. What's the minimum value of this function? Negative 16 is the minimum. Okay, that's the vertex, right? Well, what's the minimum value of the other one they gave us? Negative 8?
No, it's not.
So the vertex is negative 8?
No, it's not.
Oh, so how should we fix it to put it in vertex form so we know the coordinates of the vertex? Let's complete the square. This is one of the easy ones. What's in front of our x squared? So q of x equals, you guys just do it. Complete the square. These are the simpler ones. X squared plus 2x plus something. So maybe we ought to just finish this out. We're going to add, what's half of 2? 1. 1 squared, right? Minus 1 squared. Minus 8, right? Just real quick, how many of these 1 squares do we add here? So we got to subtract 1, unlike the ones on the page before. All right, so what's this become? X plus 1 squared. Wow. Minus 9. Cami, is that what you had? Oh. Yep. So what is the vertex? Negative 1, comma, negative 9. Cami, you kept saying negative 1, 9. My guess, I suspect that you wrote negative 1, negative 9, and just said 9. Because just mark. So what is the minimum value of this function? Negative 9. What's the answer?
The chart.
1, 2, 3, 4.
3.
For sure. All right, 3. All right. On to this one. Go ahead. Yeah. All right. Yeah. How does she get out like that? It's like, does she wait to like turn around or something?
You look like Mike then.
All right.
You were walking right there looking at her papers and she's like that. She passed the left. So we need to walk around.
Slippery. Yeah, go. And okay. All right. This is we're going to complete the square, but there's one little difference in this one. Do you notice anything different about this?
It equals 12.
It equals 12, right? So what we have here is an equation, right? And when we complete the square, what do we add? B over 2 squared, right? And then we usually do what immediately? Subtract it again, right? Why do we do that? Right, so we don't change the value of the thing, of the expression, right? But now we have an equation here, right? So if we want to put it in this form, all right, everybody think about this. If on the left side of the equal sign, I add 6 over 2 squared, am I going to subtract it or am I going to do something different? An equal sign's like a balance beam, right? Yeah, whatever I get. Whatever you do to one side of the equal sign, you do to the other. Right? So instead of subtracting it again from this side, we're going to do what? Add it to the other side, right? To keep it in balance. See how it's a little bit different than the other ones? Because we were on the other ones, we were staying on the same side, so we had to add it and subtract it to keep it the same. Now we're going to add it to both sides of the balance beam thing, right? Okay. So they want to know the value of P. In other words, like when we get in there. So let's complete the square on this. X squared minus 6x. What are we adding, kids? Plus, why are we so unsure? Plus what? 3? Squared. Yeah. Why did everybody just say 3?
I didn't say 3.
But the people that said 3, why did you just say 3 and not 3 squared?
I was just thinking of the number. I would have said.
You can't forget the square because it's called completing the what? Okay. Now instead of subtracting it again, right? Plus, what does we call it, 9, right? See, that's the difference here. We're working with an equation now, right?
Yeah.
Right? So now we're just going to add it to both sides, okay? Is that okay with you? You can add to both sides of the equal sign, right? All right, that's all we did. See where I added 9 here? See the equal sign? I don't want this to tip over, so I added it over here too, so it's the same, right? Okay, that's all we did.
So x squared minus 6x plus 9 equals 21.
Well, why don't we take care of this? Is that a perfect square trinomial now? What's it become? X.
X plus 3.
How do you
What?
minus
Squared.
x minus squared?
3.
3 squared equals
21.
okay, that's all. No big deal there. It's just now wherever you do one side of the equal sign, if I add b over 2 squared to this side, I add it to the other side. All right, what's the value of our p now?
-3.
You see this thing I circled, kids?
Negative.
That's what they're asking for, right? What's the value of, maybe if I did this? See the question? It's because it's question mark, right? That's how you know it's a question.
Isn't it -3?
Oh, hold on. Yeah. Try to, because there's other simians in here. So what is the value of p? Well, I don't know what they're. Oh yeah, that thing, right? Which is actually what?
-3.
This thing, right there. And so now the complicated part is, let's find one of these things that looks just like this thing.
3.
Okay. There we go. All right then. All right. Well, number 3 is straight back to the original thing we did. We're not doing stuff on both sides. It's an equation, right? But we're not doing stuff on both sides. Because they want us to put it in what form?
Vertex.
Go ahead and do that now. You don't know what vertex is? All right, then don't say you don't. Then turn around and say you do. Because I think then you're just messing with me. It's like I'm a cat who threw a ball of tinfoil. Making me chase it.
I love hates tinfoil.
I don't know. When you ever throw a ball of tinfoil for a cat? Try it sometime. They go nuts. It's like when you tell me you don't know something, I've got to chase that down.
You have a cat? What's -2 divided by 3?
My cat is huge, but he does not want to Google it. He weighs like 20 pounds.
Sir, let's prove you right. What is it?
-1, -9.
It's -1, -9.
Yay. Is it really? Heck yeah. I told you so. Einstein knows better. I don't.
You didn't actually tell us so.
Wait, shouldn't it be -4, 9, -1 to the second power?
Right, yeah, but remember, it did technically, but when you square it, it's going to be positive.
Wait, why'd you do that?
What? What part? What did I do? The parentheses here? What do you mean?
No, I'm just a few steps ahead. Never mind.
What is this? Okay, x. What does this become? X minus 1 squared minus 9.
Oh, so it's
What comma what?
1 common. That's what I said. Yeah, I told you that.
No,
Yeah.
did not.
You said -1, -9.
Yes, you did.
That girl said that.
All right.